Hello, I'm Dr. Patrick Hwu, CEO of Moffitt Cancer Center. We're coming to you from Washington, D.C. We're at the 2025 SITC annual meeting. I'm here with Dr. Daniel Abate-Daga, who's an expert tumor immunologist at Moffitt Cancer Center. Thanks so much for being here.
Thank you for having me. Hi. So I had a presentation yesterday in the Rapid Oral Abstract section discussing our results on the CAR-TIL. So this is a hybrid form of immunotherapy where we expect to combine the attributes of regular CAR-T cells and tumor-infiltrating lymphocytes and getting the best of both worlds.
So you're taking immune cells from the tumor, you're growing them to large numbers, and you're putting in a gene, a CAR, to help also increase their specificity. Well, a lot of them already have a receptor that recognizes the cancer. Why do you think putting in an extra gene is important?
Correct. So the hope is that we will complement the natural reactivity of the TIL that is mediated by the TCR, the polyclonal response based on TCRs, with the HLA unrestricted recognition provided by the CAR. But most importantly, and the focus of the presentation yesterday, was that we think that the TIL are better equipped to get into the tumors, and the trafficking is relevant, especially for solid tumors, and that's where we reported. So essentially, we compare side by side how well the CAR-T cells derived from peripheral blood and the CAR-T cells derived from TIL were able to get into the tumors in a mouse model of autologous TIL and tumor cells. And indeed, as we had hypothesized, the CAR-TILs were more efficient in getting into the tumor and staying there for several weeks.
Oh, that's really interesting, because the T cells in TIL, tumor-infiltrating lymphocytes, they're from the tumor.
Right.
So you hypothesize that they could actually get back to
Yes.
the tumor better. So even if their receptors don't adequately recognize the cancer, as long as they get into the tumor, the CAR gene can then give them the specificity to kill the cancer, but the TIL aspect helps them get into the cancer more than peripheral blood, because right now a lot of the CAR therapy is from blood cells. You put the CAR in, but you're saying TIL cells probably get into the tumor better than blood cells.
Correct.
Makes sense.
Indeed, as we have hypothesized, the CAR-T cells derived from the TIL were more able to get into the tumors than the peripheral blood CAR-T cells, but we also found something interesting, which is that if we compared unmodified TIL with the TIL that have a CAR, the TIL that have a CAR also were more efficient to get into the tumors, and probably the CAR is helping them stay there and be retained in the tumor mass. Otherwise, the other TIL could probably egress and get back to circulation. So that's something that we are currently exploring to try to understand the mechanism and use that information to inform the new iterations of our therapies.
Well, it's really exciting. You're putting together two main T-cell therapies, TIL therapy, granting T-cells from the tumor, and CAR, putting a receptor in the cells.
Correct.
So, very exciting. Congratulations on this work. Very innovative.
Thank you very much, and thank you for having me, and have a good conference.